Welcome to EDU World Space.
In this problem, we're going to be deriving some formulas for the velocity at perihelion and aphelion of an object in orbit using conservation of angular momentum and conservation of energy. So for the first part, part A, we're trying to prove this equation given right here for the ratio of the velocity at perihelion, Vp, over the velocity at aphelion, Va. Try to prove that it equals 1 plus e divided by 1 minus e. The tools that we're going to use to get there are angular momentum, which is the position vector r, cross the momentum, which is m times v. And then we also know that at perihelion, that position vector is a times 1 minus e, and at aphelion, the radius vector is a times 1 plus e. So those are the things that are going to be useful for us. Okay, because we know that angular momentum is conserved, then that means that the angular momentum at perihelion should be equal to the angular momentum at aphelion. So that's LP is equal to LA. Because at perihelion and aphelion, the velocity is directly perpendicular to the position vector r, that means that this equation just becomes L equals R times M times V. So what we can plug in for the angular momentum at perihelion and aphelion is the radius at perihelion times mass times that velocity at perihelion should be equal to the radius at aphelion times mass times the velocity at aphelion. The mass is constant, of course, so those cancel out. And next I'm going to substitute in our formulas from above. So the radius at perihelion is a times 1 minus e times the velocity at perihelion is equal to the position vector r at aphelion is a times 1 plus e times velocity at aphelion, Va. All right. Next, I'm going to basically just divide, do a little bit of algebra, rearranging things. So if I divide both sides by Va, then I'm going to have Vp over Va over here, and then divide both sides also by that term right there, so that the right side of my equation ends up being what I already had, a times 1 plus e over that term, a times 1 minus e. My a's cancel, and I end up back with that equation that we were trying to get. Velocity at perihelion over velocity at aphelion is equal to 1 plus e over 1 minus e. In the next part of the problem, we are trying to find formulas for the square of the velocities at perihelion and aphelion using conservation of energy. The energy during orbit is going to be the sum of the gravitational potential energy, U, plus the kinetic energy, K. And there's a formula in the textbook given, which is over here on the right, that the gravitational potential energy is gmm over r, and the kinetic energy is 1/2 mv squared. So the sum of those two terms is the total energy. Because the total energy is conserved, we can set those two equal to each other at perihelion and aphelion in order to derive this equation that we're looking for Vp squared and Va squared. Along the way, we're also going to need the results from our previous problem, which is the ratio Vp over Va is equal to 1 plus E over 1 minus E. Okay, so let's go. At perihelion, we have negative G, capital M, lowercase m, over R, and this is going to be Rp, plus 1/2 m Vp squared. And that's going to be equal to the energy at aphelion, which is negative G mm over Ra plus 1/2 mVa squared. Now I'm going to use two things here. Let's try to solve for first the velocity squared at perihelion, Vp. So in order to do that, I'm going to need something to substitute in for VA in terms of VP. So I'm just going to solve this equation over here for VP. Actually, other way around. I'm going to solve it for VA in terms of VP. That's what I want. Sorry. So that should be VA equals, I'm essentially going to multiply VA over to the right and then take this other term that's currently on the right and divide it off to the left. So I will have, because I divided this term, it's now the reciprocal of what it originally was, 1 minus E over 1 plus E times VP. That's just rearranging this equation right here to solve for VA. All right, so I'm going to substitute that in for VA, and then I'm also going to substitute in the formulas, same ones that we used in the previous part of the problem for the position vector r at perihelion, which is A times 1 minus E, and at aphelion, A times 1 plus E. Okay, now lots of substitution. One thing I can also do is my masses all cancel out. If you notice, every single term has that lowercase m, so I can cancel all of those out. Just saves me a little bit of writing. All right, so I'm going to have negative G, capital M, over RP is A times 1 minus E, plus, let's see, VP squared, that's what I want. I'm going to leave it as is, over 2. That's the 1/2, the over 2. And then I have negative G, capital M, over RA. I'm going to replace with A times 1 plus E. Plus, all right, so now I've got my VA, which again, I'm going to replace with this term over here. So it's going to, excuse me, it's going to now be 1 minus E over 1 plus E, all of that squared, VP, also squared, and then all of that is over 2. So, or 1/2 of that, I could say. Stick that 1/2 out in front. Next, I'm going to rearrange my equation. I'm going to try and get both my VP terms on the left side of the equation and both of my GM terms on the right side of the equation. So here's VP squared, and then this 1/2 times all that business squared times VP squared, I'm going to subtract that off over here. So minus 1/2 times, this is 1 minus E over 1 plus E, and all of that is squared, VP squared. Okay, equals, my original term on the right was negative GM over A times 1 plus E. And then the similar term with the 1 minus E that was originally on the left side of the equation, I'm now adding over to the right side of the equation. So now it's positive GM over A times 1 minus E. Okay, now let's do some algebra. I'm going to factor some stuff out. So on the left side of the equation, I'm going to factor out a VP squared over 2 from both, times VP squared over 2 with that factored out is 1 minus. Okay, and then I'm actually going to expand the stuff I have in parentheses there. So 1 minus E squared is 1 minus 2E plus E squared over 1 plus 2E plus E squared. That's going to be useful in my next step, so just hang on and you'll see about that. Equals, and then from both of these I can factor out a negative GM over A times, okay, I'm going to eventually want to combine these two fractions in my algebra, so I'm going to give them like denominators while I'm also doing this factoring, kind of doing multiple things in the same step. So originally this is 1 over 1 plus E. I'm going to multiply numerator and denominator by 1 minus E. So that'll be 1 minus E over, well, 1 plus E times 1 minus E, that's just 1 minus E squared. So that's the term on the left, plus, okay, originally the denominator was 1 minus E, so I'm going to multiply numerator and denominator by 1 plus E. And again, the denominator is now that like term, 1 minus E squared. So 1 minus E times 1 plus E. All right, next step. VP squared over 2. And then I'm going to do something similar with this fraction. I'm going to take my 1 and I'm going to make it 1 plus 2e plus e squared in the numerator and the denominator so that I can combine this fraction. So 1 plus 2e plus e squared is now the numerator and the denominator. 1 plus 2e plus e squared. So that's really just 1. And then that's minus all of this business that was originally in that numerator, which is 1 minus 2e plus e squared. Okay, so that's the left side of my equation. It's getting bigger, but it'll eventually get smaller. And then we have negative gm over a is our coefficient on the right, times, now that these have the same denominator, I can combine their numerators. So 1 plus 1 is 2, and negative e plus positive e, those e's just cancel out. So it's really just 2 over 1 minus e squared. Simplifying the left side of my equation, I've got VP squared over 2 times, let's see, so 1 minus 1 cancels, and then positive 2e, and then minus a negative is going to be plus 2e, so I actually can't cancel that. It's 2e plus 2e. So now it's 4e. And then positive e squared minus e squared. So those do cancel out. So it's just 4e in the numerator over, I'm going to collapse this back down to what it originally was, which is 1 plus e squared. Okay, equals negative gm over a times 2 over 1 minus e squared. Okay. Oh, you know what? I just realized we're supposed to actually have an e over here on the right side of the equation. I dropped it a couple of terms back. Did you catch my mistake? Good for you if you did. So here, when I factored out the gm, I actually should not have factored out that negative because only one of the two terms was negative. So the first term, this one, 1 minus e, that one was negative. So it'd be like negative 1 plus e. And the other term was positive, 1 plus e. So then my 1's are the things that cancel, and then this actually would be 2e in the numerator up there. So carrying that through to the rest of the steps. Okay, so 2e is what we have. Great. Okay, so I've got a 2e on the right side. On the left side, I have 4e in the numerator, 2 in the denominator. So that also becomes 2e. And then given that, I have 2e on the left and 2e on the right. All of that business cancels. So just simplifying what we have written currently, it's VP squared over 1 plus e squared equals, oh, we got rid of the negative as well. When we fixed that mistake earlier, we unfactored out the negative. All right, equals gm over a times 1 minus e squared in our denominator. Okay, so then I'm just going to take it up here actually while we've got a little bit of room. Things are getting smaller, so I can do that. VP squared. I'm going to multiply that 1 plus e squared over, and I'm going to expand it as well. So I've got gm over a times 1 plus e times 1 plus e, because it was 1 plus e squared, over the 1 minus e squared is the same as 1 plus e times 1 minus e. So now one factor of 1 plus e goes away, and I'm left with exactly the formula that we were trying to derive. VP squared equals gm over a times 1 plus e over 1 minus e. Then we have to do essentially all of those calculations again, except now we're going to be solving for VA squared instead of VP squared. So in blue here, I've just written out that same formula that we started with, equating the total mechanical energy at perihelion to the total mechanical energy at aphelion, and copied out again the same equations that we used when we were starting. to solve the problem. And this time, instead of solving for the A in terms of VP, we're going to do the other way around. Now I'm going to solve this equation on the right for VP in terms of VA, which is simply just multiplying the VA to the right. So 1 plus E over 1 minus E, that stays the same, times VA. I'm going to substitute that in place of VP. So my next step will look like this. Negative G. Oh yeah, again, we can cancel out all of the M's since every term has a lowercase m. So G capital M over RP is A times 1 minus E plus 1/2. Here I'm going to substitute in that formula for VP, which is 1 plus E over 1 minus E, quantity squared, times VA squared, equals negative GM over A times 1 plus E plus 1/2 VA squared. And we're going to get the VAs on the same side, so it will be, let's see, VA squared over 2 times all that business, 1 plus E over 1 minus E, which I'm going to go ahead and expand right now. It's 1 plus 2E plus E squared. That's 1 plus E squared. And then 1 minus E squared is 1 minus 2E plus E squared. And so that is this term right here that I just wrote out. I have to do that one minus the term from the right side of the equation, which is the simple VA squared over 2, equals, I'm going to get all my GMs together. So adding over the GM that was originally on the left, that's GM over A times 1 minus E, and then minus GM over A times 1 plus E. Factoring, I have VA squared over 2 times 1 plus 2E plus E squared over 1 minus 2E plus E squared. And then again, just like in the previous part, this would be minus 1 after I factor out the VA squared over 2. But I'm going to turn the 1 into 1 minus 2E plus E squared over 1 minus 2E plus E squared so that I can combine those fractions. And on the right side, I'm going to factor out GM over A. And I'm not going to screw up the negatives this time. So now I know it's just positive 1 over 1 minus E, which, again, let's do the, instead of 1 over, we'll save ourselves a step. Get rid of that 1. And let's go ahead and make the denominators like terms again. So it'll be 1 minus E squared because both denominators are now going to be 1 minus E times 1 plus E. So the term on the left was already 1 minus E in the denominator. So I did a 1 plus E multiplied numerator and denominator minus the term on the right already had a 1 plus E in the denominator. So I multiplied by 1 minus E in the numerator and denominator, so that both have a full denominator of 1 minus E squared, which is 1 minus E times 1 plus E. All right, simplifying. VA squared over 2 out front times 1 minus 1 goes away. 2E minus negative 2E means that turns into 4E. Positive E squared minus E squared, those go away. So 4E over 1 minus 2E plus E squared, which is equivalent to 1 minus E quantity squared, equals GM over A times 1 minus 1 cancels. E minus negative E is 2E over 1 minus E squared All right. And then we got to solve this for VA. Once again, I can simplify that. 4 over 2 is just 2. I've got a 2e on both sides of my equation. So this 2e cancels with this 2e. I can just divide that off entirely. And I'll have VA squared equals GM over A times this 1 minus e squared. I'm going to multiply over to the right and expand. It's 1 minus e times 1 minus e. And the denominator, 1 minus e squared, is 1 minus e times 1 plus e. So my 1 minus e's cancel, and I'm left with what I was trying to find. VA squared equals GM over A times the group 1 minus e over 1 plus e. In the next section, we are trying to derive the formula for the total angular momentum of the system. And we're going to be now using the reduced mass and total mass based on those center of mass coordinates. So that means angular momentum's formula is the position vector r cross the reduced mass mu times v. Remember, this is on the assumption that some singular, some one particle with a reduced mass of mu is orbiting about the focus at a distance of r, and there is some amount of mass m located at the focus. So that's the center of mass coordinates that we are working with right now. And some things we need to know along the way are that the reduced mass mu is equal to the sum of our two masses, m1 plus m2, over, oh, actually, you know what? I said that wrong, sorry. It's the other way around. It's the product over the sum, not the sum over the product. Let me go back and fix that. Ooh, if it lets me. Okay, there we go. That'll work. The product of the masses, m times m, over the sum of the masses, m plus m. Okay. Furthermore, at perihelion and aphelion, we know that the radius and the velocity are perpendicular to each other. So we can just say that the angular momentum equals r times mu times v. Then if we use what we know about, let's say perihelion, we know that r at perihelion is equal to a times 1 minus e. And we derived in that previous problem that Vp squared equals Gm over A times 1 plus E over 1 minus E. Sorry, RP was A times 1 minus E. There we go. All right. In our equation, we want V just like regular old V, not V squared. So we'll erase the squared here by square rooting both sides. So that's the formula for Vp. So if we go ahead and take those things and we substitute them into R mu V, what we get is the angular momentum at perihelion, which we know is same as the angular momentum everywhere throughout the orbit, since angular momentum is conserved, equals the R we're going to replace with A times 1 minus E for perihelion times mu times that velocity at perihelion, which is what we've got in green over there, Gm over A times 1 plus E over 1 minus E. Okay. The next step of the algebra involves moving things into the radical, which personally I find it easier to see how that algebra works if I use exponents instead of radicals. So I have a to the power of 1, which is the same as a to the power of 2 over 2, for example, times 1 minus e to the power of 1 times mu. That one we don't really have to worry about. Times the, how do I want to write this? We'll say, we'll leave the GM in the radical because that's just going to stay in the radical. That's where we want it anyway. Times the A that's currently in the radical, but it's in the denominator. So it's the negative exponent. That's like to the negative 1/2 times 1 plus E. That's a numerator, but it's inside the radical, so it's to the 1/2 times 1 minus E inside the radical, so 1/2, but in the denominator of the radical, so negative 1/2. Okay, and then when we simplify these, I've got an a to the power of 1 and an a to the power of negative 1/2. So in total, that's a to the power of positive 1/2. I just add the exponents. 1 plus negative 1/2 is positive 1/2. So that puts my a inside the radical. Let's see, I still have the mu outside the radical here, so I'm going to write that. The GM was already inside the radical. Now I said my a has moved inside the radical. All right, my 1 minus e does the same thing. I had 1 minus e to the power of 1 and 1 minus e to the power of negative 1/2 for a total exponent of positive 1/2. So again, now that is inside my radical. The square root is the same thing as to the power of positive 1/2. That was 1 minus e. And then my 1 plus e also had a positive 1/2, so that just stays positive 1/2, which is inside the radical. Okay, and I've taken into account all of my terms. Okay, so now simplifying, we have the angular momentum equals mu times GMA. 1 minus e times 1 plus e is just 1 minus e squared. And I've dropped the subscript p perihelion for the angular momentum because, as we said, given that angular momentum is conserved, if it's true at perihelion, this formula must be true everywhere.